Hi, everybody. Thanks to be here for this talk about fast logs. I'm Nicolas Fränkel. I've been working for 20 years in IT, and for 18 years, I've held technical roles such as developer and team lead. And 2 years ago, I switched my career path and became a developer advocate. And from this history in consulting, I'm very interested in DevOps. Even before it became hype and widespread and so on, I was interested in monitoring your application, how to better collaborate with the ops, this kind of stuff. I work for a company called Hazelcast. Hazelcast has two products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So instead of having a list or a queue or whatever inside a single JVM, for example, you can distribute it all over the network with sharding and replication. And the other is Hazelcast Jet, and we do stream processing in memory, leveraging the in-memory data grid. This talk won't be about any of those. Today we are talking about fast logs. And this is Java code. I guess you are not all Java developers. Probably only a few of you know Java, but this can be pretty easy to understand. I have a logger. I have a method that sets the level, debug, info, error, whatever. I have a message, and I have a parameter. And when I do this talk on site, I ask what can go wrong. So I will give you couple of seconds if you can write in the chat what you think can go wrong with this line of code. And probably, I guess that some of you already had this issue before. So please don't leave me alone. Just cut maybe null. That's true. Cut maybe null, and then it will explode with a null pointer exception. However, it won't actually affect your logs. Get price could be a long-running operation and will always be executed. Yeah, that's exactly the answer. So in that case, and I have something to, sorry, I was being too fast. The issue, yes, it might be null, but it will explode. And even though that's not super great, it's acceptable in that case. But here I have the same codes, and I'm logging before and after, and then I'm running these codes, and it takes time because, as was mentioned on the chat, cut.getPrice might be an expensive operation, and even though it's debug, it will get like called in every time. And if we check what does get time, in that case, we don't do something fancy. I'm just like simulating a long computation. But the main issue is every time this will get executed, and we will wait for that. And it's not great. So if you are more on the developer side of things, you might have good ideas. And then you have guards. So in that case, even if get price still takes the same time, now I'm very, very fast because I'm in debug. I'm not in debug. I'm in info or above, and debug is not enabled. So I'm not executing the cut.getPrice method. I'm not calling it. The problem with that kind of writing is that, well, it's not that great. You must always remember to do it. You must read it every time. And of course, there might be issue because there might be some stuff like that, which again is not great. You have this desynchronization again. So it must be enforced in one way or another, and not super great, right? Depending on your language, you might start being smart by doing kind of these things. We have a logger, and we have what I call a lazy logger. And this kind of lazy logger, instead of executing the method and passing the results of the method, we pass the computation itself. We pass a reference to the method. And what does this lazy debug do is we pass the supplier. So we wrap the computation in an object, and this computation is only run when it's debug enabled. So here we get the best of both worlds. It's easy to write, and it still gets executed very fast. You can see it's still, you have a bit of lag between the main 2 and the main 3. It's still a bit more expensive than the bit 2, which takes 1 millisecond, but it's still much better than just waiting for 5 seconds. So perhaps this is acceptable to you. That depends a lot on your context, of course. But this is one way to do it. And you don't need to create this lazy logger yourself. If you have been using Logback, if you have been using Log4j2, then it's out of the box. You don't need to write those lazy loggers yourself. And so, well, it's already something. And as you will see in this presentation, it's hard to focus on a single point. We need to address a lot of different stuff to have fast logs. For example, we saw the fast logs from the point of view of a developer or an architect, and now we go to the opposite side from the infrastructure point of view. If you are logging on disk, then logging to disk, writing to disk has a definite costs. But actually, it depends a lot on the medium you're writing to. If you are writing to a SSD, or if you are writing to a network file system, for example, it will be completely different. So just choose the right hardware for your logs, and automatically your logs will be faster. Now, getting again back to now perhaps some configuration, because it's not really a developer concern. Think about when we write to a file, when we write to a stream, every time we open the stream, we write bytes and we close the stream. And you do that for every message. And if your messages are very short and you have got a lot of messages, then you're just like every time opening and closing for nothing. So perhaps it sometimes would be good to say, okay, we accept that we won't write synchronously, because by default logging is blocking, but we will write asynchronously. So we open the stream, we just send several messages to a buffer, and after some time, when the logging framework decides that the buffer has enough data, then we write the data to the disk, we close the stream, and we open it again. And again, this is just configuration, because most logging frameworks allow asynchronous logging, in Java at least, and I believe others do as well. So the configuration for that is easy. You just add this async appender, and you just say, hey, I want to use the async appender. Here is a logback configuration for you. It's a pretty widespread logging framework in Java. Now, when you start thinking about async and buffer, you've got some interesting concepts that creep up. The first is, what is the correct size of the buffer? I mean, the smaller the size, the more you will open and close the stream every time, so the less performance benefits you will get. But on the opposite side, the larger the buffer, the higher the higher number of data points you will lose, of messages you will lose, if for some reason there is a crash, because then it will be in memory, it won't be in the disk. That's one of the first issue that you need to configure and to think. And again, there is always a trade-off involved. The second is, at what point will we discard messages if the buffer is too full? Like if your application logs faster than your logging framework writes, then what should we do? What would be the correct threshold? For example, Logback allows you to say, okay, if I reach a certain threshold, then I will discard automatically debug and info messages, and I will keep the important ones, the errors, for example. So that's, again, something you need to think about. In general, however, it's not only the message you are interested in. You probably need associated metadata. The first one that you absolutely need is a timestamp. You really, really want to have the timestamp with every log message. In general, you also want to have the log level and perhaps the thread name or the class name or even the line number in the file. Well, you need to think how expensive it is to get them. Like, for example, the line number, it's possible in Java, but it's super, super expensive. So if you let the framework can do it, but you will lose a lot of performance. So your architect might say, okay, I don't accept this kind of trade-off. I want to have fast logs, but I still want the line numbers. And then it will be up to the developer to write the line number by him or herself. And well, he or she might make mistakes. So again, it will be faster, but it won't be as reliable. Gone is a time where it was the only data we needed. In general, what you will do is you will do log aggregation. So you will take all those log files that are distributed all over your machines, all over the nodes of your cluster, and you will read them and put them in a central place. And the central place might be Elasticsearch, might be Splunk, might be Graylog, might be anything. And when you start doing log aggregation, then you suddenly find yourself having additional metadata. And the additional metadata is the source. What file did I read? What host did I read from? What environment, like development or production or wherever. If you are running in one of those clouds, then probably the zones or the region or both might be important to you. So now you've got a lot more data to manage. And it's not as important as when you try to make sense out of your logs. Because if you just dump the logs in a big chunk of data, well, it will be very fast, actually. But it's not the case. In general, you dump the logs because afterwards you want to search them. And it happens a lot when you do some debugging. And so if you are focused on being very, very fast on write, you might say, oh, I don't need any schema. I will just dump everything. And if we are in the realm of data, we say we dump everything in a data lake. And then when you do some reads, that it's up to the reader to try to make sense of the format and to understand how it was made and to create it and to accept that, hey, in this field, sometimes there is an integer and sometimes there is a date and sometimes there is a string. And that's not very comfortable because when you have a production incident and you need to read the logs to make sense of what happened, well, it's now the time where you need to read fast. So perhaps taking a bit more time to write might be more interesting when you search, because when you read, it will be much, much faster. I will take a sample architecture because it's the architecture I'm most familiar with, but probably it can be, you can make a parallel with your own stack. I will be using the ELK stack, the Elastic Kibana stack, sorry. So you have one component that is generally dedicated to read the log files where they are written. And then you have Logstash to parse the log messages and to create the schema. This looks like this in general. Your application writes the log, and then you have a FileBit daemon that will read the file, and then it will get the logs, and then you will send the log to Logstash. And then Logstash you will probably have a grokking pattern. You have created grokking patterns in the past. They are very complicated stuff, but then they structure your line of message into some JSON format. And this JSON format you can send to Elasticsearch, and then because it's JSON, then the schema that will be created will be just what you want. And then when you search, then you will have all your fields. And actually the problem is the following. You create on the application side this kind of message. Of course, in general, it's one line. And what you want in the end is this kind of message. And for that, you need logstash in the middle. And why do we need logstash? Why can't we create JSON directly? That's common sense. If we create directly this message, then we don't need logstash. We can send it directly to Elasticsearch and it will be done. And it's not that hard to do. Actually, I have this main class that does it for me. Here I'm using Logback again. Here I'm directly outputting the JSON format. So instead of having this kind of output, I have this kind of output. Granted, for you, it's harder to read, but again, gone are the days where you would like go to the machine and try to make sense out of the log file in isolation. You aggregate everything, then you put everything into Elasticsearch. So it makes a lot of sense to have this kind of output. And this is easy to do. This is just simple configuration. You don't need more. Just set the pattern that you want, and presto, you will directly have the output that you want. And then you have not only made your logs faster, you have also simplified your architecture a lot. You have less moving parts and it's faster. In general, you probably want this kind of benefits. Now, if we can go much further. For example, you can have events. Probably you might have heard that depending on your logging framework, you don't need to write the file and then to scrap the file. What you can do is directly like send events to whatever data store you want them stored in. And this is not only true for logging frameworks. For example, Docker, you have the same. You can have a Docker driver that sends the log events directly to somewhere else. So instead of writing and then scraping and processing and storing, you can directly send the events. It will be much, much faster. But again, there is a trade-off. If something crashes, then you will just lose whatever those log messages were. Perhaps that's not so comfortable. Also, perhaps it's better to lose a bit of performance and to have like a background thread that reloads the configuration file when it's necessary, instead of having something like just like removes all debug and info and just logs error and fatal, but then you have an issue and you see nothing on the machine. So you want to get deeper and to have more insight into your application. In general, if you don't have hot reload, what you need is you stop the application or the Docker container, and then you restart it with another configuration. And perhaps it's not what you want. So in that case, again, there is a trade-off involved. You might want to always have hot reload, and perhaps it will be used once per year or twice per year. It will be less performant because there is this background thread always trying to reload the configuration that you will never use. But when you need it, then you don't need to restart the machine. Also, might be a good idea. Something also that you need to think about is that if you approach your business to implement whatever I told in this talk, and they will ask you for a budget, and because it brings no business value, they will probably say, no, we cannot do that. Like, hey, we want faster disk. Yeah, but you know, that's not gonna bring us any business benefit. You might want to advertise the fact that the logs, they are not only technical, and the business, they can also benefit from business logs. Here I have shown you like FileBeat and Logstash and Elasticsearch. Those are the Elk stack, but actually you've got a lot of logging options. I'm not prescriptive in any way. In my previous company, they were using syslog-ng and Kafka. And one of the reasons is because they wanted to have business events sent to Kafka. So the reason why that is we were a cloud provider company, and we wanted to invoice the customers, and the logging framework was responsible to send the right usage metric. So we stored them into Kafka. And of course, if you store something into Kafka, you store it on disk again, it's going to be persistent. It's going to take more time to write to disk, because even if Kafka is very, very performant, still it's much slower to write to disk whatever you are using than just send a network event and be done with that. Here I have a little demo of the previous setup that I showed you. I have a Docker Compose file. Oops. I have a Docker Compose file. I have a Java application. It's Hazelcast Jet, but it can be any Java application. And here I've configured it to use the Logback file here that is here. And this Logback file is also outputting JSON. And then I have a FileBeat that scraps this log file. And then I have Elasticsearch, and finally I have Kibana. And I already started it because I didn't want to lose time to start it. So here is the results. I have those events, and yeah, I had I had issues because, as you can see, there are some log messages that do try to have that do contain characters that are part of JSON. So I have a parsing issue here. But when there is not an issue here, I have a normal message, and I have the thread name, and I have the class name, and of course I have the timestamp. And I in the Docker file, as you could see, I have nowhere I have Logstash. So it directly is sent to Elasticsearch from FileBeat directly to Elasticsearch, and we can see that here. Just scrap the file, the log file, and I send it to Elasticsearch, and it's done. So again, much faster, less moving parts, and yeah, it just works. So in this talk, I touched the previous points. From the developer side, you just should pass computations instead of executing the method, getting the result, and then passing the results. Consider the physical file system you write to if you are on the hardware side of things. If you value speed more than reliability, and there is a big if, then you should go asynchronous for sure. Think about the metadata that you are using. Some of it can be like really, really expensive. And just in case, consider whether hot reloading your configuration, is a good idea or not. Schema on write will always be slower, but the alternative is much worse. So always do schema on write, even though it's slower. Don't be just focused on performance. Just like widen the system you are looking to, because if you try to optimize for this single slice, that's not being so great. And then, of course, if you can send JSON directly. The important part here is to have fast logs. It's not only the developer responsibility or the architect responsibility, it's really a team effort. So if you want your logs to be fast across all the logging chain, then everybody who is involved needs to be incentivized to improve the performance. If you don't, you will have a bottleneck, and all other optimization that you have made, they will have been for nodes. Something that is very close and dear to my heart. I know a lot of people who say, hey, you should do this or you should do that, otherwise you will be doing it wrong. I'm very careful. I'm trying not to be prescriptive, because it's always a matter of trade-off. So it depends a lot of your context. Some people, they will probably value speed in their context more than reliability. Other will say, okay, we accept that it will be slower, but we prefer reliability. So before doing anything, just think what is more important to you in your context. If you are dealing, as I mentioned, with business logs and you bill your customers from them afterwards, then reliability might be very important. So you might want to write to Kafka cluster, for example. If it's just debug messages, then events without writing anything to disk might be a better idea. So thanks for having heard me. You can read my blog where I publish weekly blog posts. You can follow me on Twitter. And when I did this session last time, I had a very interesting question, and it was about logging additional metadata. Like, hey, you want a business transaction ID or the customer ID or whatever. And the issue is, if you write it into your message, then of course you will need again to parse this message. However, depending on your logging framework, you might be able to use something called MDC. And with MDC, you can directly write a JSON formatted or whatever formatted with the customer ID or session ID or whatever directly into a tag, and you don't need Logstash afterwards. If you are interested, if you have this issue and are interested, I created this article. So thanks for your attention. And now I will check the chats to see if there are any questions. Why is there a lag in this solution? I assume that the question is about the passing the lambda. I'm not a JVM expert, so I cannot answer this question. But even though I'm not an expert, well, you need to create the computation anyway, and it takes time. And I don't know exactly where the time is spent, but it's probably about creating the computation. Again, it was 1 millisecond, 40 milliseconds, 5 seconds. So it depends on if you are doing real-time trading, for example, yeah, 40 milliseconds is a lot, but for logs, I'm not sure there might be that much. What about escaping when processing JSON via log configuration? Yeah, that's exactly the problem. Probably what you will need is in your, I didn't check to be honest, in your Logback configuration, you could add an additional transformer that would escape the JSON that you're already producing in your message. But probably you are not producing a JSON in your message. What you are producing is, yeah, JSON incompatible characters. And yes, you need to escape them in that case. Again, if you want to add additional fields, just look at MDC. I don't think you have to escape quotes in the Logback pattern. Yeah, yeah, Logstash encoder. Thanks, David. Yeah, you answered my question. I should probably start from the bottom. So MDC has better performance than directly adding specific metadata. No, that's the opposite. You will, if you use MDC, you will have a performance performance hiccup that I didn't measure. But on the opposite side, you will be directly be able to add additional fields in your JSON. So on one side, it will be a bit slower, but on the other side, you won't need Logstash anymore. So it's, in the end, you will probably gain. Of course, whatever I tell you, you should try to do it in your own context because, well, it depends a lot on the type of logs that you are sending, on how many messages, how many errors, how many debugs. And that's unfortunately, I cannot have all the answers. So there doesn't seem to have any more questions, and I really appreciate that you are answering all each other. That's really good, because I don't pretend to be an expert in everything. So that's good that well, we can help each other. If you didn't think about a question now and you think about it later, well, just ping me on Twitter. My DMs are open. And on that, I wish you a good rest of the conference, and thanks again for your time.